Hello ladies and gentlemen, welcome to my YouTube channel. Today we are going to discuss about resistance and the drawing of two types of connection. We have one resistance, we have one, we have parallel resistance, parallel resistance, and two, we have series resistance, parallel and series resistance. We start by defining resistance. A resistance is opposition given to the flow of current in a circuit. Let's draw our circuit. Let's start by one, series resistance. Series resistance. In series resistance, we can draw it. Let's draw a series connection. We have three resistance connected in series. That is it. Three resistance connected. This is a power source. Power source is V. This is resistance 1, resistance 2, resistance 3. This is a circuit resistance. This is I total. This is our current. Now let's do this. We know very well in a series connection, current is the same. I total equals to I1 and equals to I2 equals to I3. That is series connection. Again, we know that in a series resistance, voltage varies. V total equals to V1 plus V2 plus V3. That's voltage varies. Now, voltage V1 voltage is given by current over resistance. Now V1 equals to I current divided by resistance at 1. V2 equals to current, because current is constant, divided by resistance as 2. And V3 voltage at 3 equals to current is constant, divided by resistance 3. Now I total, current total, current total is given by, we substitute, that is voltage times resistance 1 plus voltage times resistance 2 plus voltage times resistance at 3. You know here voltage varies. Voltage 1 plus voltage 2 plus voltage 3 will give us V total, and V total is this, the product of voltage and resistance 1 plus the product of voltage and resistance 2 plus the product of voltage and resistance 3. Now the resultant is given by R1 plus R2 plus R3, and this is all about series. That is how we can derive current total in a series connection, voltage total in a series connection, and current the same, resultant resistance is the same, like that. Now we can move to our next is parallel as number 2. Parallel connection. Number 2 is parallel resistance. Parallel resistance. Let's draw it. We have a parallel. These are resistance here. The same apply. We have 3 resistance, but now connection is in parallel. connection is in parallel with the source. This one is our source of supply. This voltage, this is resistance 1, resistance 2, resistance 3. Now here we apply Kirchhoff's law. This is current total. This is current total. Now this one is this one is resistance 3. Now the current that will goes here is I3. That is I3, meaning if we apply the Kirchhoff's law, meaning this current going straight will be I1 plus I2. Whenever there is a junction, whenever there is a junction, the current will separate. Now here is our second junction, meaning that we apply Kirchhoff's law. This is the resistance 2, meaning here current that will goes here is I2. That is I2, and I1 will continue moving. That is I1. That is current 1, and the current 1 goes to our resistance at 1. Now we continue from resistance 1. There is I1 coming out. I1, sorry, this is I1. This is I1 coming out. The current leaving a junction equals to the current meeting at the junction. This is I2. That is Kirchhoff's law. Now here we have two types of current, I1 plus I2. Again, the current leaving a junction, this one, as you can see, the current leaving a junction goes to current meeting at the junction. Here you can see here we have I3, and the product of the sum of I2 plus I3 plus I1 is given by current total. Current total is coming again. Current total is leaving again. That's the Kirchhoff's law. Okay, let's derive the formula for a parallel resistance connection. We know very well here voltage is the same. V total equals to V1 equals to V2 and equals to V3. Now what will vary is the current. I total equals to I1 plus I2 plus I3. We can continue by saying that I total we substitute equals to voltage over resistance 1 plus voltage over resistance 2 plus voltage over resistance 3. This is how we derive our. Now you can see voltage total is the same as voltage is the same. V equals to V1 equals to V2 equals to V3. Current total equals to current 1 plus current 2 plus current 3. You can see there is a deviation of current. Each branch they divert, they come again, they make I total. Here they come as I total. The I3 goes in the first branch, remaining I1 plus I2. I1 plus I2 continue. There is a deviation. I2 goes here. The I1 goes. They come again. They meet and sum up to I1 plus I2. Again they meet with I3 to join and make I total. You can see here I total equals to I1 plus I2 plus I3. and I total is given by voltage is the same over R1 plus voltage the same over R2 plus voltage the same over R3, and that is how we can get the voltage drop and the current in the parallel circuit. Let's find now again the resultant. Therefore 1 over R total equals to 1 over R total equals to, that's 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. Guys, thank you for watching. Subscribe, share and like. Thank you.